Good day, students and viewers. In this video, we are going to study the trigonometric identities. First of all, the course is Math 103. It is trigonometry and coordinate geometry. And this is, we are going to trig identities. Trigonometrical identities. The first identity is the Pythagorean identity. Let's look at this. This is x, this is y, this is x, and this is r. And then theta is here, a right angle triangle. So based on this, we know that sine theta is equals to opposite over hypotenuse, which is equals to x over r. Y, because y is opposite to theta, and then r is the hypotenuse. And then what about the cosine? Cos theta is going to be adjacent over hypotenuse, which is x over r. What is tan? Tan theta is going to be opposite over adjacent, y over x. Now, but by Pythagoras' theorem that the square on the hypotenuse is equals to sum of the squares on the opposite and the adjacent. And this is it. So by Pythagoras' theorem, we have that r square is equals to x squared plus y squared. So x squared plus y squared is equals to r squared. So dividing through now by r squared, what do you have? So you have r squared over r squared is equals to x squared over r squared, and then plus y squared over r squared. But this can simply be written as, because r square over r square is 1, and therefore you have x over r all squared plus y over r all squared, but this is equals to 1, so it's equals to 1. But what is x over r? X over r is cos, therefore cos. But because of the square, we put cos square theta plus. What is y over r? Y over r is sine, so you have sine square theta, and this is equals to 1. This is called the Pythagorean identity. So sine square theta plus cos square theta is equals to 1. And so we have equation 1. Now from equation 1, we can subtract sine square theta from both sides. So subtracting sine square theta from both sides of 1. What do you have? You have cos square theta plus sine square theta minus sine square theta is equals to 1 minus sine square theta, because we subtracted sine square theta, we subtracted sine square theta from this side, but sine square theta will go with sine square theta, therefore you have cos square theta is equals to 1 minus sine square theta, and this is equation 2. So you see, whenever you see 1 minus sine square theta, you can simply represent it with cos square theta. Now again, subtracting 1, subtracting cos square theta from both sides of equation 1. We are referring to the Pythagorean identity. So from the Pythagorean identity, you have cos square theta plus sine square theta. So we are asked to subtract cos square theta is equals to 1 minus cos square theta. So cos square theta will go with cos square theta. You are left with sine square theta is equals to 1 minus cos square theta. And that is equation 3. So whenever you see 1 minus cos square theta, simply put sine square theta there. And then we continue like that. So therefore, now similarly, dividing through equation 1, the Pythagorean identity, by sine square theta. What do we have? We have cos square theta plus sine square theta is equals to 1. But dividing by sine square theta. Dividing by sine square theta. Now, here divided by sine square theta. What do we have now? This is equals to cos square theta over sine square theta. Cos over sine is what? So cos over sine is going to be tan, is going to be cot square theta plus sine square theta over sine square theta. This is equals to 1. But what is 1 over sine square theta? 1 over sine is cosec. So therefore we have cosec square theta. And that gives equation 4. Whenever you see cot square theta plus 1, just write cosec square theta. Now subtracting 1. Subtracting 1 from both sides of equation 4. What do we have? We have cot square theta plus 1 and then minus 1 is equals to cosec square theta minus 1. 1 will go with 1. You have cot square theta is equals to cosec square theta minus 1. So whenever you have cosec square theta minus 1, just put cot square theta there. Now, dividing equation 1, dividing the Pythagorean identity 1 by cos square theta. What do we have? When we divide, what is the Pythagorean identity? We have cos square theta plus sine square theta is equals to 1. Now by cos square theta over cos square theta over cos square theta. What do we have? We have that this is equals to 1 plus tan, because sine over cos, we have tan square theta, and that's equals to 1 over cos is sec square theta. And then maybe we call this, if we call this equation 5, then this is going to be called equation 6. Now subtracting 1 from both sides. So we subtract 1 from both sides of equation 6. What do we have? You have 1 plus tan square theta minus 1 is equals to sec square theta, and then minus 1 because we subtracted 1. So 1 will cancel 1. You have tan square theta is equals to sec square theta minus 1. Whenever you see you have sec square theta minus 1, you just write it as tan square theta. And so you have equation 7. There are so many identities. We can also derive another identity, but before we go ahead with other trigonometrical identities, or we call them the compound formula, we give example. I don't know which number to put, but this is just an example. Example is saying, show that we are to prove that A sec theta over cot theta plus tan theta as a fraction is equals to sine theta. B 1 over 1 plus cos theta plus 1 over 1 minus cos theta is equals to 2 cosec square theta. And we have the proof. A. To prove, it means we have to take the left-hand side and show that it is the same thing as the right-hand side using the usual operation as we know. It is clear, very clear, that sec theta is 1 over cos theta. So now, instead of, we have sec theta over cot theta plus tan theta. You have to write the left-hand side first. So this is equals to, what is sec theta? Sec theta is 1 over cos theta. And then we have the division line. So instead, we use the division sign and just say, okay, what is the denominator now? Is cot. But cot is cos theta over sine theta. Why? Because sine theta is equals to cos, so tan theta is equals to sine theta over cos theta. But tan is the reciprocal of tan. Cot is the reciprocal of tan. And then so it is cos theta over sine theta when we have cot. And then plus tan, which is equals to sine theta over cos theta. So this is the denominator. This is the denominator. Now, we have to, this is equals to 1 over cos theta divided by, we have to solve what is inside the bracket first. So we have to find the lowest common multiple. Since 1 is not a factor of the other, so we write as sine theta cos theta is the lowest common multiple. And then we multiply cos theta with cos theta, sine theta with sine theta, because none of them is a factor of the other. And so we have cos square theta plus sine square theta. Why? Because we just say, okay, now this is the LCM. So the LCM multiply by this divided by this. So when you multiply the LCM is sine theta cos theta times cos theta. You are going to have sine theta cos square theta divided by sine theta. That is equals to cos square theta. And then here you have sine theta cos theta times sine theta. You are going to have sine square theta cos theta. Then divided by cos theta is going to be sine square theta. So this is equals to, but this is equals to 1 from the Pythagorean identity. So you have 1 over cos theta divided by 1 over sine theta cos theta. Now the division symbol is going to be multiplication, and then we take the reciprocal of the content of the bracket. So 1 over cos theta times sine theta cos theta over 1. So cos theta will cancel cos theta, and therefore we have the answer is sine theta. We may solve the second example and then close the video. What is the second example saying? That the B part is saying that we should show that 1 over 1 plus cos theta plus 1 over 1 minus cos theta, and this is equals to 2 cosec square theta. So we take the left hand side and show that it is the same thing as the right hand side. So therefore 1 over 1 plus cos theta plus 1 over 1 minus cos theta, and this is equals to, so 1 over 1 plus cos theta, and then so we have this times this as the LCM. We now look at the LCM. So none of them is a factor of the other, and therefore their product is their LCM. Now, what is the LCM now? The LCM is 1 plus cos theta into 1 minus cos theta. So therefore, here we multiply and then we cross multiply because they are not factors. None is a factor of the other. Suppose they are factors of the other, then we cannot do that. Or we simply say, to be on the safer side, we said, okay, 1 plus cos theta into 1 minus cos theta times 1 and then divided by this. What are we going to have? We're going to have 1 minus cos theta. And then plus 1 plus cos theta times 1 minus cos theta times 1 divided by 1 minus cos theta. We're going to have 1 plus cos theta. So what is going to happen here? 1 plus 1, and then cos theta minus cos theta, meaning cos theta here minus cos theta. So we have cos theta will go with cos theta. We are going to have 1 plus 1, and this is equals to 2 over, what is this? Is the difference of two squares. That is the difference of two squares, of course. What do we mean by this? So whenever you have 1 minus 1 plus cos theta and then 1 minus cos theta, what you have is 1 square minus cos square theta. But what is this? So you can expand the bracket, please. Not even saying that it is the difference of two square only. One can say that 1 plus cos theta into 1 minus cos theta. 1 times 1 is 1. 1 times cos theta, we have minus cos theta. So cos theta times 1, we have plus cos theta. Cos theta times cos theta, we have minus cos square theta. So minus cos theta plus cos theta is gone. 1 and then minus cos square theta. And that is why we have it here. And so this is equals to 2 over 1 minus cos square theta. What is 1 minus cos square theta? We have just finished it from the previous video that this is sine square theta. 1 minus cos square theta is equals to sine square theta from one of the identities. So you have sine square theta. But this is the same thing as saying 2 times 1 over sine square theta. But this is 2 times, what is 1 over sine square theta? This is equals to cosec square theta as required.